Let us apply Green's theorem to evaluate the integral over closed curve x dy minus y dx, where c is the curve enclosed by the circle x square plus y square equal to a square. For that purpose, we write the statement of Green's theorem, or rather formula by Green's theorem. By Green's theorem, integral over closed curve, remember we need the curve to be a closed curve, p dx plus q dy equal to integral over region enclosed by that closed curve del q del x minus del p del y dx dy. So that's what Green's theorem says. Now we have a choice of calculating the left hand side or the right hand side. Let's write the exact expression. In this case, if we compare what we are given and what we have in the formula, we have p dx and we have minus y dx. So we can write it as integral over closed curve. Instead of p dx, we have minus y dx. And then q dy. Instead of q dy, we have x dy. So we took p equal to minus y, q equal to x. Once again, we took p equal to minus y and q equal to x. If we apply Green's theorem, then that should be equal to integral over region p dx, del q del x. So del x of q. What is q? Q is x. Del x of x minus del y of minus y, p, del y of p. P is minus y dx dy as it is. Now we want to apply Green's theorem, so we better evaluate left hand side or right hand side. We observe that if we want to evaluate our left hand side, then we have minus y dx plus x dy. That integral has to be evaluated. Along a closed curve is enclosed by the circle x square plus y square equal to a square. That's quite difficult. However, we want to apply Green's theorem, so it doesn't matter which side we evaluate because answer will remain the same. So let's evaluate the right hand side. So we want to calculate integral over region del x of x is 1 minus del y of minus y is minus 1 dx dy. Now what exactly is the region? Well, that is the region enclosed by the circle x square plus y square equal to a square. So we have 2 dx dy. We have integral over region 2 dx dy. We can take the 2 out, so we have integral over region dx dy. Now since we have integral over region, that region is simply a circle, so this integral will be equal to pi into a square. That region gives us area. So we have simply computed the expression that integral over closed curve x dy minus y dx is just equal to 2 pi a square. It's just equal to 2 pi a square. In other words, let's write the final answer. Integral over closed curve minus y dx plus x dy equal to, that's the left hand side of the Green's theorem, equal to, by Green's theorem, equal to 2 pi a square. So in this case, we don't have to evaluate integral over closed curve minus y dx plus x dy, because it is much easier to evaluate the integral over region dx dy, and that is equal to pi a square.